Hi, I'm John Mark Lumayag, and for today's video I am going to explain the round robin algorithm. This type of algorithm is used in multitasking operating system or time-sharing operating system. So round robin is preemptive. What do you mean by preemptive? Preemptive refers to the ability of the operating system to interrupt a currently executing task in order to start or resume another task. In round robin scheduling, each process is assigned a fixed time or time quantum. In this example, the time quantum is equivalent to 3. If a process does not finish within its time quantum, it moves to the ready queue. We need the ready queue to help us solve the Gantt chart easier. So, at first, we have 0 arrival time, which is P1. So, we put P1 in ready queue. Now since P1 is the first in the ready queue, CPU will allocate P1 for how many period of time? For only 3 unit of time. Then check the burst time for this process. The total burst time of P1 is 8. So 8 minus the quantum time, it will now become 5. Since it is only processed for 3 unit of time, then at 3, P1 will be removed at the CPU and again back to the ready queue. But before putting P1 in the ready queue, we have to check if there is another process arrive while P1 is in process. So check out the arrival time of another processes. The arrival time of P2 is 5. So we're not gonna put it in ready queue. Now the arrival time of P3 is 1. So while P1 is running, at time of 1, P3 has arrived. So P3 is now in ready queue, P4 is 6, and P5 is 8. So before 3, only one process has arrived and went in ready queue. Now we're gonna remove P1 from the CPU and put back to ready queue. So in ready queue, the next process is P3. So remove P3 and allocate to CPU. P3 for 3 unit of time. So 3 plus 3 unit of time is 6. So the burst time for P3 is 7. So 7 minus 3 is 4. Cancel and 4. Now check the arrival time again. P2 arrival time is 5. So we'll put it in the ready queue. P2. But as can you see here, at 6, P4 arrive. At 6, P3 will be preemptive. In this case, we're not gonna put P3 then P4 in the ready queue. If we encounter this kind of situation, then we will always put the newly arrived process in the ready queue. So we put P4 first, then P3. P5 come at 8, so this will not in the ready queue now. Next, P1 will be removed in the ready queue and P1 will be allocated. P1 removed in the ready queue and allocated. P1 would need 5 unit of time, but we can allocate CPU for 3 unit of time. So 6 plus 3 is 9, and 5 minus 3 is 2. Now at 9, P1 will put in ready queue, but before putting P1, we will check if there is any process has arrived while P1 is running. So at the time of 8, P5 has came in the ready queue, then P1. So we're gonna put P5 and P1. Next in the ready queue, delete P2, then CPU will allocate P2. Check out the burst time for P2. It is 2. P2 only required 2 unit of time, so 9 plus 2 is 11, and P2 is done. So we're not gonna put P2 in the ready queue because P2 execution is already done. Now next, P4. P4 only needs 3 unit of time for completing its execution. So we're gonna put P4, and 11 plus 3 is 14. And again, P4 will not go to ready queue because P4 is also completed. So we're gonna cancel this P4. Now next process is P3. The burst time for P3 is 4. We can only allocate 3 unit of time, 14. So we're gonna put P3. 14 plus 3 is 17. Also minus 3, this will now become 1. Now we will put back P4 at the ready queue. P4. Because it still needs 1 unit of time for its completion. We don't need to check if there is any new process arrive while P3 is running because all the process is now in the ready queue. Now next process is P5. The required burst time for P5 is 5, but we can only allocate 3 unit of time, so it still has 2 unit of time. Gonna put P5, 17 plus 3, 20, and we're gonna put P5 in the ready queue. P5. Next is P1. P1 remaining time is 2. So P1 will only run for 2 unit of time instead of 3. Oh, P1 run for 2 unit of time, so 20 plus 2, 22. Now P1 is also done. Sorry, this is P3, not P4. P3. Next is P3. P3 required only 1 unit of time. P3 will run for only 1 unit of time, so 22 plus 1 is 23. Only P5 left in the ready queue. P5 only need 2 unit of time, so we will run this for 2 unit of time. We're gonna cancel, and also P5 run for 2 unit of time, so 23 plus 2 is 25. Now P5 is also completed. Now the ready queue is empty, so we will now stop this round robin algorithm, but we still need to determine its completion time, turnaround time, waiting time, and response time. So to check out the completion time, we have to start from right to left. For P1 we have 22. P2 is 11. P3 is 23. P4 is 14. And P5 is 25. Next, the turnaround time. To get the turnaround time, we need the completion time minus arrival time. So 22 minus 0 equals 22. 11 minus 5 is 6. 23 minus 1 is 22. 14 minus 6 is 8. 25 minus 8 is 17. Next is the waiting time. To get the waiting time, we need the turnaround time minus the burst time. Turnaround time is 22, and we need the original burst time, which is 8. So 22 minus 8 is 14. 6 minus 2 is 4. 22 minus 7 is 15. 8 minus 3 is 5. And 17 minus 8 is 17 minus 5 is 12. And last is the response time. To get the response time, you only need the first allocated time minus the arrival time. So P1 here is 0, so 0 minus 0 is 0. P2 is at 9, so 9 minus 5 is 4. P3 14, So wait, P3 is 3, sorry. So 3 minus 1 is 2. P4 11. 11 minus 6 is 5. So P5 17. 17 minus 8 is 9. If you want to calculate the average for turnaround time, waiting time, and response time, just add it and divide for the process number or how many process. The total value for turnaround time is 75. So divide 5 process is equal to 15. For the waiting time, 50 divide 5 equals 10. For the response time, 20 divide 5 is equals to 4. So that's the average for turnaround time, waiting time, and response time. That's it, and thank you.